50. And so what we do is we have a fan. This thing on this little stack is actually a big fan. And what that fan does is it pulls vacuum through the entire system. So what we have is like a vacuum cleaner. It literally has suction down here. So when we're attached to the stack of the vessel, we have a nice tight fit. So we're not getting a bunch of ambient or clean air inside.
So just because not a lot of people get the concept, because they see it here on the floor, so if you don't, this is on a crane and it flexes up like an arm like this. So when they take this barge and they attach next to the side of the ship, and the arm comes up like this over the smokestack of the ship. So this will be up, 100, 200 feet up out that way, and then that attaches to the exhaust pipe. So this is all like a hydraulic arm, like a robotic arm that comes up like this. It's operated by somebody down here. So sometimes people are like, how does, so just to understand this kind of like arm thing, and that was one of the big obstacles before. They used to actually have a crane with a wire and lift a big old, like what they call the sop, and they put it over the whole smokestack, which was a disaster for the most part.
Yeah, we started with a tower crane on a dock. But what we realized with the tower cranes is it causes stress because ships, we learned so much about ships that we didn't know. So what happens with the ships they lift, back and forth. They go up and down. So what happens is it's called station keeping. So at the stack, that thing's moving like in circles. So a conventional crane, if somebody just wants to put a tower crane in, it's less expensive than this. But the reason we ended up with this design is because we need something to be flexible to actually be able to move with the ship. So we use this high temperature flexible duct that gives you a little bit of leeway, and this hydraulic boom. They're going to exercise this boom for
Oh wow!
That joint right there, that rotates. Yeah, the thing completely. You know what this is? This is a concrete pump. So we took a concrete pump and we just put all the heavy wall pipe on it, run it on a hydraulic power back.
We purposed it. I would just say that's the joint that allows this thing to be straight up because it rotates right there.
Right. But there are a bunch of knuckles and it kind of does this. So Lalo's going to operate, and this is how they operate. And it looks like a video game.
The other question I have, Ruben, is you guys have a vacuum. Couldn't you just put this thing airtight and let the pressure of the stack push the
It would, but then what would happen is it would blow that back. Bought a used barge, and we cleared the deck off it, did all the testing, make sure the integrity was there, and did a marine architect with it. So we can do, this is set up for 2 pipes, so 2 stacks that are emitting from the stack, and so we can set this up for 4. So our engines, usually they're running 1 or 4. Yeah, 1, 2, 3, or 4.
So you would then put a T on these 2?
No, what we do is that little Y, we would change to, we have one, we call it a Quinta. It comes down, goes across, and it has 4 on it. And so like the break bulk ships, like a lot of the ships you get in Texas, they run 3 or 4 auxiliaries. And it's not the size of the vessel that creates the greater amount of emissions. So in other words, we can get an 18,000 TEU container vessel, but puts out less emissions than a 6,000 that's got 300 reefers on it.
The bigger one's probably a newer ship, right?
Yeah, but it's newer, but it has a bigger load. It's bigger, it got a lot more. But it depends on how many reefers they have on it. They have 300-400 reefers on the ship. They're putting out double the load. So. Yeah, this one works. It usually takes about 15 minutes to connect. From the time that we connect our barge up to the vessel, we can be connected and ready to go in 15 to 20 minutes. And so Eduardo's operating that unit right there with that
low control.
So they just basically, he'll go up to the tower, he'll go up on the ship, or he can just sit here on the deck and get over.
And when I see this stuff, Ruben, I'm just like, how bad do you want to get in compliance? How bad do you want to be in attainment?
Right.
Houston has struggled, and it's like, there's things that you can start employing right now that we can start to cut some of this stuff down.
Absolutely.
Especially with the amount of maritime traffic that Houston alone sees.
Well, the other thing just to think about, and we're going to have a conversation tomorrow with the advisory board about the VW settlement. And we're putting in comments, but we're going to talk about how we're putting in comments so that we make sure we're covering all the different seaports and being able to utilize those resources to implement something like this. Because this captures, what's the percentage of emissions captures?
We're 99% capture.
That's what
efficiency.
you've been telling that efficiency, and I was like, what does that mean?
That means that at the stack,
Right?
we're proven to capture 99% of the emissions coming from that stack. And so you have a capture efficiency, then you have a treatment efficiency.
Yeah.
Our treatment efficiency is anywhere between 95 and 98%.
Okay.
We've been up to 99 on many cases.
And that's what you do with the pollution after you've already got it, right?
Yeah, and I'll walk you through
Okay.
that. I'll show you how basically. So here, I just want to kind of show you the ease of the operation, because with a tower crane, you got to be like right perfect. You can't be off. With this, it gives us flexibility to go all the way around. We have a 360-degree reach, so we can go all the way around. So it doesn't matter what side of the ship the stack is on. It could be on the left side, it could be forward, it could be way out, and so we can go alongside the hip of the vessel. So we can so far we've been able to do every single ship, I think, except for one. And the reason why it was such a the hull concave down so yeah. And what would happen is this railing, and we made it detachable, but the barge would go up underneath the ship. So to be able to do those ships in the future, we have what we call a spacer barge.
Okay.
So it's a small barge that goes alongside us, and between us and the ship, it puts us off the ship. And the other reason for the spacer barge is safety, because they drop containers, and then, I don't want them to drop one on our guys. So that does happen. Not on our guys, but it does happen. They do drop them in the water.
Did you guys hear about the
cool.
Ben Franklin? Have you guys heard about the Ben Franklin? So Ben Franklin is a post-Panamix ship. It's a 18,000 container ship. It's one of the largest ships in existence. It's the largest ship that has visited the United States, right?
That's correct.
And they actually have used this system on that particular ship, the largest container ship to visit the United States.
Wow.
That's 18,000 TEUs.
How did
So-
Ben Franklin do?
It was great. We barely reached it. I mean, the closer you got to her, she was massive. Yeah, but it was really cool to know that a lot of the thought that's gone into the engineering and the rigging of the system, we were able to reach that vessel.
How many mechs do you have on board?
How many of these systems? We only have one.
Okay.
Yeah, so these AMECS units are been around for a little while, but we only have this one. Now we're building two more right now.
Yeah.
We literally ordered the parts. We hope to have them in operation by December. Here in California, the shoreside rule currently says that you have to reduce 50% of your emissions while visiting the port in California. January, it moves up to 70%. And so a lot of this, it's a big impact on the shipping industry, because a lot of them don't know how they're going to be able to meet that requirement. So therefore, we're in a hurry to build several more units. And so our plan is to